So far, we have examined several useful formulas to help us solve probability questions. However, these formulas are of little value if we cannot determine which one to use for a given problem. So in this lesson, we will learn how to rewrite questions so that it is clear which formulas we need to use. To highlight some important strategies, we're going to solve this question in a very systematic manner. Now in this question, we are tossing a coin 2 times, and we want to find the probability that at least one toss turns up heads. So we could rewrite the question as follows. Now while this does summarize the probability that we need to find, it is not obvious which probability formula should be applied here. So let's see if we can rewrite this so that it provides better insight into the solution. To do this, we'll ask what must occur in order to have at least one toss turn up heads. Well, in order to have at least one heads, we would need to have the 2 tosses yield 1 head or 2 heads. So we can rewrite our probability as shown here. Now we can see that we have a probability question that involves the word or. We want to find the probability that this event occurs or this event occurs. Now in an earlier lesson, we learned that there are 2 slightly different formulas for probability questions that involve the word or. These formulas depend on whether the 2 events are mutually exclusive. So to determine which formula to use, we'll ask the question, can both events occur together? Can we toss a coin twice and get a result of 1 heads and 2 heads at the same time? The answer is no. So these 2 events are mutually exclusive, which means we'll use this formula. When we apply this formula, we get the following. So we can see that we need to find the sum of this probability and this probability. Let's begin with the probability of getting 1 heads. Now at this point, it is unclear how to determine the probability of getting 1 heads. So we should ask, what must occur in order to have 1 toss turn up heads? Well, for this to occur, the first toss would have to turn up heads and the second toss tails, or the first toss would have to turn up tails and the second toss heads. Since we now have a probability question involving the word or, we should determine whether these 2 events are mutually exclusive. So we'll ask, can both events occur together? Can we toss a coin twice and have this event and this event occur at the same time? The answer is no, which means the 2 events are mutually exclusive, and we can use this formula. When we apply the formula, we can rewrite our probability as the sum of 2 probabilities. At this point, we have the sum of 2 individual probabilities. So let's work on this probability. This is an AND probability, and we saw in an earlier lesson that there are 2 different AND probability formulas depending on whether or not the 2 events are independent. To determine whether the 2 events are independent, we'll ask the question, does the occurrence of one event affect the probability of the other event? For example, if we get heads on the first toss, does this affect the probability of getting tails on the second toss? The answer here is no, so these 2 events are independent, which means we'll use this formula. When we apply this formula, we get the following. Now let's work on this probability. This probability is similar to the probability we just examined. Since the 2 events here are independent, we can rewrite this probability as the product of 2 probabilities. At this point, we have broken the question into its most basic components. For example, here we have the probability of getting heads on the first toss. We cannot rewrite this probability to be any simpler. So we can now start finding individual probabilities. We'll begin with this one. The probability of getting heads on the first toss is 1/2. The probability of getting tails on the second toss is 1/2. The probability of getting tails on the first toss is 1/2. The probability of getting heads on the second toss is 1/2. At this point, we can multiply the values within each set of brackets, and finally we'll add these 2 fractions. So the probability is 1/2 that we get 1 heads when we toss a coin twice, which we can now add to our calculations. Now we need to find the second probability, getting 2 heads in 2 tosses. Well, what must occur in order to have 2 tosses turn up heads? For this to occur, the first toss must be heads, and the second toss must be heads. So this is an AND probability, so we need to test for independence. To do so, we'll ask, does the occurrence of one event affect the probability of the other event? The answer here is no, which means the 2 events are independent, so we'll apply this formula which says we can rewrite the AND probability as the product of 2 probabilities. Now that we have broken the probability into its basic components, we can evaluate the individual probabilities. The probability of getting heads on the first toss is 1/2, and the probability of getting heads on the second toss is 1/2. The product is 1/4, so the probability is 1/4 that both tosses turn up heads. When we add this to our calculations, we get the final sum of 3/4. So the probability is 3/4 that at least one toss turns up heads. Now let's examine a second way to solve the same problem. We still want to find the probability of getting at least 1 heads. Now when we see a question involving at least or at most, we should consider using the complement, since this can often provide us with a faster approach. So we can rewrite our probability as follows. Now what does not at least 1 heads mean? It means having 0 heads. So we need to find the probability of getting 0 heads in 2 tosses. Well, getting 0 heads is the same as getting 2 tails. And to get 2 tails, we would have to get tails on the first toss and tails on the second toss. This is an AND probability, so we must check for independence. Since the occurrence of this event does not affect the occurrence of this event, the events are independent. So we'll use this formula to rewrite the probability as the product of 2 probabilities. Now that we have broken the probabilities into their basic components, we can evaluate the individual probabilities. The probability of getting tails on the first toss is 1/2, and the probability of getting tails on the second toss is 1/2. So the probability is 1/4, which means the probability is 1/4 that we get 0 heads when we toss a coin twice. When we add this information to our calculations, we get a final probability of 3/4. So using the complement, we can see that the probability is still 3/4 that at least one toss turns up heads. Now in this lesson, we examine some of the questions you should be asking in order to take probability questions and break them down into their most basic components. These questions include, what must occur to get this outcome? Will it be faster to use the complement? Are the events mutually exclusive? And are the events independent?